Test? Test. Okay. Something was wrong with my mic a moment ago, but I seem to have the correct mic input sorted now. So hopefully everyone can hear me. The waveform says that you can hear me. Excellent. I'm going to start with a little bit of a recap for where we are. And also just a note, excuse me, I've had a cold the last week, so hopefully my voice will do well here, but I've got a couple of hours available to me today. So I'm going to switch over to the camera. Hey, yeah. I don't know what happened here. My audio looks a little hot on my side. I'm going to pull that down. Does that sound okay? Yeah, I see that. Switching scenes, I don't know what happened. My OBS Studios audio devices got a little screwed up, and it had defaulted to default audio device, and I don't know which audio device was the default one. I guess it hasn't been that long since I streamed last. Okay. So, I was saying after I switched over to this input, and none of you heard me, that I'm going to do a little bit of a background as to where we are and where we want to go today. Now, first of all, I should say that I have not done any real development at all off camera since I started streaming. I added a few tests after the last stream, but that's all that I've done. So I'm trying to stream and record every part of this process, but I wanted to do all of this math and everything on my own and figure out how to do it myself. Yes, shadow puppets, but I don't actually know any shadow puppetry things. And trying to knock out that shadow actually caused it to blow out the white balance on the paper. That's slightly better. Camera keeps refocusing though. I wonder if I can fix the camera focus. I'm going to try to do that real quick. Properties. Resolution, no. No, I don't see anything like that. Okay. So I've got my game, and it consists of a bunch of line segments, right? And then we have a camera, and the camera is looking in some direction, like this. And I cast out these rays, and we see which wall segments we hit, and then we know what to draw at that location. I'm not going to go back over all of that. If you're interested in all those details, I recorded all of that earlier. I do plan to edit this all down into something more succinct eventually, once we actually have gotten somewhere interesting with all this. Now, I didn't know how to do so let's just say this ray is a line segment, and it goes off very far. And this wall is a line segment. I didn't know how to do the math for line segment intersections, and when I Googled how to do line segment intersections, the math that I found back was things that didn't make any sense to me. I did, however, know how to do line intersections. And like I said, I was trying to figure out all of the math on my own. And so what I have today is if I have a camera and I have an array is just a start point and an angle, then I take that and I convert that to a very long line segment because that's going to say how far out the camera can see at this particular point. And I have these wall segments everywhere. And then for each step of each frame, I take all of the wall segments and I actually convert those into lines. And I convert the rays for the camera into lines. And then I do a bunch of line intersection tests. And that is fundamentally what we were dealing with when we were last streaming, and I was trying to fix these problems with our ability to walk through walls that happen to be straight in front of us. Because the math goes weird when you have a line that is vertical. So one particular person who's been watching this whole time and has submitted a few pull requests keeps trying to get me to do segment intersections, and I have to fully agree I need to go to doing segment intersections. So I'm going to switch back over to my desktop now, and hopefully my audio keeps working. It is. Good. As far as I know, no loss in audio there. So I have this whole set of tests. I have geometry, and we can see these things because we added a bunch of tests for them. I've got a line. A line has got an origin point and a slope, and I've got a segment. And segment has things like toLine, where it has to calculate the slope. And if the slope is vertical, then it gives not infinity because infinity becomes weird, but it gives a very, very steep slope. And all of this is just goofier than it needs to be. What I really need is a function that can tell me if two segments intersect, and I should be able to greatly simplify the code for, well, like this code right here for seeing if segments intersect. Because right now I have, does this ray intersect this set of segments? And to do that, I convert the ray to a segment like I was just saying, and I pass that to intersecting segments, and then I convert that segment into a line, and then I do a bounding box test, and then I convert each of the input segments into a line, and I check to see if they're parallel, and if they intersect. And if they do intersect, well, if they're not parallel, then they have to intersect, right? Because that's how lines work. Then I check to see if they're in bounds of the bounding boxes of both of the line segments. All this is just more complicated than it needs to be. All this needs to go. All of the line code needs to go. All of the conversion code between rays and segments and lines need to go. But I still don't necessarily know the math for how to do intersecting segments. So I'm going to try something. We have all the tests, right? I've got my geometry test, and I have test all these segments on, well, I'm going to have to get rid of a lot of these tests once I remove the line stuff. But I have test segment on segment, and I have test segment intersections. So theoretically, the test will still pass if we do this correctly. So I'm going to try something. It's going to go like this. I'm going to go over here to ChatGPT, and I've toyed with this a little bit. We're going to see how well this works. Given let's see. Let's see, it's get this correct. These are data classes. All right, those are floats. I do use type annotations in many places, but not all. I have definitely been inconsistent about it, and I don't know. I don't know what I'm doing. That's, just kind of the gist of it. Now, did I name that begin and end or start and... That's start and end. Okay. Now, my float looks a bit flat. Oh, float. Okay. I think this is approximately correct. Now, this code doesn't have to actually be compilable or anything. I could have given it named tuple, whatever, data class. That should be good enough. Keep switching back and forth between the wrong things here. I have a lot of people that I interact with who say that Chat, GPT, etc. is just a glorified autocomplete, and I think you're using it wrong if you use it in that way, because I have seen that you can get something like this to give you remarkably interesting output. So, given a set of Python classes, point and segment here, add a member to segment that returns the intersection between two segments. See what it does. This time it's relying on using a third-party library, which it hasn't in any of the other times that I have played with it. That is funny. So we'll just have to ask it nicely to not use Shapely. I've played with this, like I said before, and it's given me basically two different versions of this. Sometimes it calls that the denominator, and sometimes it calls it the determinant. But this seems to be approximately the same answer as I got last time. So let's see if this works and does what we want it to do. I'm going to copy that. I'm just going to paste that in right here. Yes, I am using... Oh, that went very wrong. Why did it go so wrong? I hate it when that happens. Let's try that again. I'm just going to use Vim. Yeah, IDE was helping. Yeah, Vim has gotten, I feel like, smarter at this lately. Let's see. Or NeoVim has. No, it has not. Yeah. How do I turn off auto indent on paste? Auto indent lines. No, I wanted that as an option. You know what? What about it? No. Oh my goodness gracious. Why is this more difficult than it should be? Simple text editor, mouse pad. What is happening right now? Why can't I edit, copy and paste something? Oh my goodness gracious. It's usually not this difficult. I fairly regularly copy and paste things from my VM to my host. Yes, I'm using a VM for all of my work today. Where did this give off? Check if the two segments intersect. Okay. Not expected this to be the difficulty today. Oh, and look, now I have a bunch of extra spaces too. Okay. Am I good here? T and U, I missed the comment in my deletions. Oh no, that's right. Okay, good. This is just ridiculous, isn't it? I wonder what happens if I can do a drag and drop of text. Can I do that? What happens? Oh, that worked shockingly well, actually. Except I have the same section of code twice. That's human error, not AI error. Okay, so I have an intersection function. Very good. Let's just go ahead and put this in here. And we'll see if it does its job. And we'll see if we can start simplifying this stuff. So I have a segment intersection function, and I use it. Why is this? Oh, right. Too many blank lines. Okay, intercept. Intersecting segments, intersecting ray. Okay. Intersecting segments. I want to clean up all of this code. I don't need the input line anymore. I've got segment and segments. For segment. Intersection equals input dot intersection of segment. Okay. Let's just say for the sake of argument that I am prototyping this in Python as an exercise in learning Python because I don't know Python. Accept that as canon for the moment. I'm learning new things, Fred. You should learn new things as well. Okay, so if I have an intersection. So if it was not none, right, then I know I had an intersection. So let's just append this to our results. And someone can tell me if there's a better way, Pythonic way of doing this all in one step. I want to, okay, yeah, so I still want this distance, and I want, okay, yeah. So those are all, that's what I want in here. It's just P now becomes intersection. And segment stays a segment. And return result. Where do I work? Or is that in reference to me, Fred? I am self-employed, have been for a very long time now. I work by going to people's companies and teaching them C++ best practices, mostly. All right, so, I mean, if that worked, then it worked, and I should be able to, like, run this thing, and the game will work? Well, that does not look good. That does not look good. Oh, goodness, that does not look good. Chat GPT, you screw me over here or what? I mean, do I have to do something like that? I don't think I have to do something like that. Not normally, no. All right, so we need to see if our tests succeed. Segment intersections. All right, don't work. Xavier prefers is not none. All right, so did I do something wrong or did it do something wrong? Let's... Well, it did something wrong. I mean, that just seems that that's got to be what happened here, right? Check if two segments intersect. Calculate the point of intersection. Return the point. Start y, end x, end y. Start x, start y, end x, end y. All right. Let's put a breakpoint in here and debug this. What? Why is that saying that x... Oh, because self versus other. All right. Negative 1, 0, 1, 0. Negative 1, 0. 1, 0. And that should be 0, negative 1, 1, 0. Zero, negative 1. Okay, all right. I didn't realize none was a singleton object. All right. So they are not parallel. Fine. Halfway through that one. Why is it not giving me a mouse over for you? Give me a mouse over for you. Oh, it's right here. Okay, fine. Okay, so it's saying that the intersection happens outside of these two line segments. But we are approximately right here, and we have a horizontal line that goes from -1 to 1, and a vertical line that goes from -1 to y of -1 to y of +1. So their algorithm is broken. All right, ChatGPT. You have some ants and some splaining to do here. Hmm. Yep. You must make sure that the order of the points in each segment object is correct. The two segment objects are passed to the method in the correct order. That's not helpful. No, that didn't actually change anything. Yeah, it gave me almost the exact same code. Seriously. Oh, not useful. This doesn't help. This doesn't help. Nowhere in this code is the equal operator used. I did. So the point was to see if it would work. We have tests. No, wait, oh, right. I have to start all over with this thing. Still getting the same denominator. Yeah, none of this actually changed. It's still order dependent. And the equal method is never actually being called anywhere in this intersection code, so it's not helping anything. Yeah, all it changed was adding the segment, the equals code, right? The denominator is the same. That code's the same. All right, I'm going to start with a whole new one and see what happens. Yeah, I know that equals equals would call it. My point is there were no equals equals in the entire line intersection code. It's the same basic concept over again. I'm going to try one other thing. I'm just going to go back to this just to clarify. Yeah. Nowhere in the intersection code is there an equals operator called on the segment itself. So when it gave me this and told me that that somehow solved my problem, I really don't see how that solved my problem. No, not line. Just out of curiosity. It's interesting enough to see if it can solve these problems, absolutely. It's actually usually pretty good at giving you these things. So this looks like the same code again, right? Oh, that's interestingly different. If y minus... What did it do different there? So this time it called it the determinant, but it did the same basic thing, right? Denominator versus determinant. It's got more parentheses. It's an experiment, folks. Goodness gracious. I wanted to see if it could give me an answer. So that is UA divided by denominator. And this one is T, which is right. So it did basically the exact same thing. So all of these things are determined. I'm going to ask it again. Hey, Ollie. Thanks. Itis wiki does bio. My bio? I don't have a bio on Wikipedia. If the direction of the line segment is reversed, okay. Yeah, I'm not important enough to have a bio on Wikipedia. The leftmost or topmost point of the line segment, and the endpoint is the rightmost or bottommost point of the line segment. The start point comes before the endpoint in a specific, oh thanks, sure. Has a consistent direction. Both conventions are valid. Okay. When using the line segment intersection function I provided earlier, the convention uses a second one. The start point of the line segment comes before the endpoint in a specified ordering of points. Okay. If you're working with line segments that have been defined in a different way, you may need to reorder the points before using the line intersection function. Compare the x-coordinates or the y-coordinates to start endpoints and swap them if necessary to ensure that the start point becomes before the end point. All right, so that's an answer. Finally. Oh wait, so Python. I didn't actually, so this needs, right, okay. Let me see. Sure. So I'm ordering them based off of y coordinates, swapping them if necessary. And for the person who said that they couldn't believe that I would copy a solution that I don't understand from ChatGPT, I really don't see how that's any different than copying a solution I didn't understand from, say, Wikipedia. And I did already make a point of saying when I started streaming that this is math that I know that I don't understand. I did it the overly complicated way with line intersections, but I know that that's very inefficient and it's causing a lot of extra conversions and a lot of extra hand waving to get the math to even work out at all. So if I can borrow an implementation that does work and adapt it to my needs, then it's documented here and I'll comment it and say, I don't fully understand how this works. In my opinion, it's not too far off from accepting a pull request from someone with math that I don't understand. Test failed. Which test? What is happening here? To me, this is also just an experiment to see if a tool like ChatGPT can actually do this thing. I keep doing the exact same thing over and over again. Debug. It's stopping at the breakpoint that I wanted it to. Okay. So if x1 is greater than x2, then I'm swapping. Yeah, that was what I was trying to do. Wait, it's still -1. Didn't actually change anything. I thought I reordered the points like it told me to. Let's restart this. It's an interesting point. I'm going to do this for the fun of it. We'll see what it does. It's an interesting, I just think it's an interesting experiment. All right, I'm going to leave that for a moment, but then I'm curious enough to see what this is doing again. So no reordering actually happens at all here. Interesting. Right. Yeah, they were already passed in an order. Oh, but then do the whole system need to be reordered as well? Yeah, it is surprisingly good at translating, I agree. This version checks the x coordinates. That is literally exactly what I just did. And that didn't actually fix the problem, did it? X1 is greater than x2. That is exactly what I just did. That doesn't solve it. Huh. The UI changed? On this version, determinant dx dy. Oh, that's weird. I never noticed that on all of these versions. There wasn't a negative on the bottom one. Determinant is rotation invariant. Don't think you need to spot the coordinates. Okay. Huh. Wait, why does it begin with a negative in some and not a negative in others? That's weird. See, you can only trust an AI as far as you can throw it. I actually got it lying to me pretty good about trigonometry yesterday. It was rather frustrating. I was asking it to calculate some function, and it's like, see, this is clearly the answer. Then I said, really, could you test that? And it says, no, this is the answer. And I said, can you explain why your two answers just varied? Oh, look at that. All I had to do was get rid of the stupid negative. So yeah, it was lying to me. It just gave me the wrong answer in the first place. How bizarre. Just remember, computers lie to you, kids. So this appears to be correct and passes the test. And we should be able to get rid of these based on the comments in the peanut gallery, plus the fact that the AI seemed to be lying to me. Interestingly, it doesn't seem to be any faster. But it works. And we will make a note. All right. I just want to get rid of a bunch of other code now. Are we okay with this version? I know some of you are complaining if I don't fully understand the math, then I shouldn't be using it. I don't understand the math. It's interestingly, I had people complain to me that it's weird that I tried to do this without knowing what I was doing in the first place. So if we're all okay with this implementation, then I'm going to start removing a bunch of line-specific code. I'm going to let you all discuss that for a minute if you have anything to say while I commit these changes. Let's make sure that they make sense. The geometry changed. Oh, and I added some vertical space in geometry test. Fine. Though that's going to, let's do this. Okay, that's fine. Yeah, all right. Oh, I'm getting... All right. All right, now I am going to start axing all of these things that are like special vertical slope nonsense and lines. So, to line, we're going to get rid of that. Ray still needs to segment. All right, I don't need this intercept. This is a bad name anyhow. It should have been intersect, not intercept. Segment to Ray. Do I still need segment to Ray? You don't think I do. Segment to Ray. Right. I used that in the actual Raycast generator. All right, that's fine. The slope property. Return line. I don't need this anymore if I'm getting rid of all the line code. All right, let's see where else slope is called. That's to see if a point is on a segment. Oh, right. All right, fine. I guess I'll leave that in. Right. That does what it's supposed to do. And then how many tests do I have that are all dependent on lines? Segment properties. All right, why does this fail? Segment does not have an attribute line. So I'm going to get rid of all of these line tests. Need to get rid of the parameter as well. Test point segment. Make sure these do not throw. Okay, right. So I do care about segment to Ray there. Okay. I don't care about lines. What are these tests? Test for test array properties. I don't care about that. For that, just care that I can calculate segment values. Why is there a bookmark here? Delete bookmark. Round trip, segment to ray, ray to segment, right? I did that. Test line intersections. Don't care about any of those because we don't have lines anymore. All right, let's see if all these tests pass. They do. This is my kind of a diff. Let's see what we got. Excuse me. Diff. All right. Yay, lots of code removed. Our favorite kinds of diffs. All right. You know, I should probably actually make sure this does still play. Well, the test passed. That means it must still be perfect, right? I wonder if it's actually a little bit slower, interestingly. I think it might be. Because I was able to hit 45 frames per second before doing these changes. Would never have expected that. Huh. So I'm no longer relying on some cached properties that I was able to previously rely on. I think probably had a pretty significant impact on the performance of the code. And by the way, thank you to whoever it was who gave me the fixes. You know, there's definitely math in here that I've accepted that I do not understand in the form of pull request. Someone gave me the fixes for this calculation of the aspect ratio relative to the screen and everything, and that looks like a square. That's amazing. That's correct. The prints are only like once every 100 frames or something. That's not throwing me off too much. I'm going to test something else. So just out of curiosity here, let's redo this. Yeah, that is quite a bit faster. Oops. I really did not expect that. Wait, hold on now. What was that? Just some sort of weird... I'm back to... Was it just my system running, feeling slow at the moment? What is happening right now? Because I am back to 30 some odd 40 frames per second again. And I did go back. Just have to blame the nature of PyPy on this. Make sure I'm using the correct version. Yeah, I'm using the correct version. That is weird. Okay, fluke. I don't know what to say. I'll be right back. Intermission.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn switch off and replace on speaker post. Warning, high voltage. For your own safety, do not attempt to repair or remove wires. Do not attempt to open heater unit. If you need assistance, please notify the theater box office or concession manager.
Top quality hamburgers, the most popular snack in the country. We serve them plain or garnished to your taste.
And now, on with the show.
You've seen the show. It was quite a treat. But now you'd like something to eat, so right this way to the concession stand serving...
Yeah, I don't know. Garbage collection? I don't know. I do think it's an interesting question of to whether or not you should, for example, have some sort of cached method lookup on line intersections. I mean, it would help you a lot while stagnant, like while in one spot. It would keep redrawing the same frame over and over again really fast. And it would matter maybe some while rotating, but I don't know. I mean, it'd be fascinating. Let's just try adding an LRU cache to this real quick. What does that look like? I don't want a cached property. I want the LRU cache. The vertical slope global can go. I am using it somewhere. Let's actually. Well, all right, fine. I'm gonna do a functools just out of curiosity. We're gonna try this LRU cache on here. I just want to know what it does. It actually slows it down. That's actually kind of interesting. Yeah. I'm not actually shocked because it's a lot of data for it to manage for no particularly good use case. I mean, yeah, I could try the full cache, but I'm creating... It's interesting because then it becomes really important on which way I order the segment cache to the segment intersection detection. I need to make a note to myself here. Okay. Yeah, why not? I'll do a full cache, not just the LRU cache. Oh, even slower. No, I just ran out of memory. There's so many rays being cast. It's not worth it. Okay, let's get rid of that cache. And let's go ahead and look into this vertical slope thing. Yes, let's do that. And see if we can do something smarter. So I use this on the segment to calculate its slope. And I use the slope on a segment specifically to see if a point is on a segment. Now, the question is, where do I use the onSegment function? And yeah, I only use it in the tests. And if I only use the slope function... Wait, why am I using it in Raycasting? Filtering duplicate wall segments. Oh, that's Maybe I should show you all what that's about. So in my map definition, if I've got a line segment, oh, this is terrible. If I have a line segment from here to here, and then I have a line segment from here to here, these are two different, let's color this one blue, color this one red. If I have these two things in the map definition, then I have an algorithm that comes through and says, well, I can actually call this the same wall chunk. If it's the same type wall and they connect it end to end like that. And I use the slope of the segments to determine if they have the same slope. Now, I could do that if I knew what this determinant was about, right? Because if I understand this correctly, where did this go? This denominator. Calculate the denominator of the t and u values for the parametric versions of the two segments. Okay, so this is the rise times the run of the change in y times the change in y of segment 2 times the change in x of segment 1 minus, so this is the determinant? I don't know, because like I said, I don't know these things. I do know them, kind of. I actually took vector geometry and linear algebra in my university classes, but that was an incredibly long time ago. And I have been relearning an awful lot of math in doing this that I haven't had a reason to use professionally since I graduated from university in the year 2000. That was approximately 23 years ago. And I find these Wikipedia articles on this stuff so incredibly obtuse. How to check if two line segments are parallel. Two lines are parallel if their slopes are equal. Right, sure. That I already knew. And this is giving me all line. Here's a line segment answer. If any pair of corresponding angles, alternate interior angles, alternate exterior angles are equal or... Yes, okay, that's not actually answering the question again. See if we can get a Quora answer. Yeah. Yes, if I know the two lines. I literally just removed that. Why are you telling me to do that again? Okay. Do the vector product of AB and CD. If the vector product equals 0, the lines are parallel or collinear. So that is the equation. That is the math that we just did by, right? That's the vector product. Cross product or vector product. So if I've got, so that's the point, right? That's what we've been looking at, right? That is what we've been looking at. Excuse me. So what do I put here? Cross product, determinant, denominator. Are these things different? Okay, so we're talking cross product, right? The cross product as a single number is essentially the determinant, apparently only in 0, 1, 3, or 7 dimensions. Oh, wait, did I missed a link, didn't I? Sorry, I'm going all over the place here. Ah, go away. Okay. Okay. Imagine that you've installed a solar panel. As the sun moves through the sky, the angle between the sun's rays and the solar panel changes. It's ideal if the sunlight hits the solar. Okay. The dot product is an operation on vectors that enables us to easily find the angle between two vectors. Hey, that's what we're looking to do, right? So if the angle between them is 0, then they're the same slope, right? Okay. For two vectors of n dimensions, then the dot product is the scalar of a times b plus a1. Okay, all right. If theta is the angle between a and b, then a cross dot b equals the length of a times the length of b times the cosine of theta. Or theta is the angle between them. Okay, right. So if the angle is 0, then let's just do a quick the cosine of 0 is 1. So if the dot product is 0, then they are orthogonal. Okay, wait. So let's look back at what this thing that we cribbed for this intersection is. This is definitely, no, right here. So that's definitely not the dot product. So the cross product itself is a vector. Okay. Right. That's what I was getting at. Okay. So this is not the dot product. Whatever this is not the dot product. It is relying on the length, or it is taking into account the length of these things. And it's saying if these two are 0, if this value is 0, then it is parallel. Don't look at me. You all asking questions about these things. The cross product produces a new vector. So to answer part of that question, so I still don't know. I'm going to go back and ask ChatGPT. I am going to. I'm going to ask it. It's the determinant of the matrix formed by the coefficients of the equations of the intersection point. If the determinant is 0, then the lines are parallel or coincident and there is no unique intersection point. If the determinant is non-zero, the lines intersect at a unique point and the function proceeds to calculate the intersection point using the determinants of two other matrices as shown in the code. Okay, so it is the determinant trying to decide how I want to go from here. So we know if this value is 0, then two lines are parallel. Two segments are parallel. I'm going to do this. Or collinear. Yeah, yes, it is definitely a duplicated code fragment. I'm trying to decide how I want to do this, computer. to avoid code duplication. Is the neat the comment that it saw the code was duplicated, or neat the comment that you're understanding the vector math that's being discussed in the chat? I'm going to take the lazy road at the moment. Lazy road at the moment. Yes, absolutely. Lazy road at the moment. Because I want to see what we can clean up in the rest of the code by doing that. So if we know that two segments are parallel, then I don't have to do the slope check anymore. I can get rid of the slope function. And I can get rid of the vertical slope constant. And this on segment only exists for test right now. So I'm going to get rid of that function. But only exists for the sake of a test. I don't want it in this code right now. So the whole point of this code was to generate a segment and then run a bunch of tests to see if I can calculate if it was on the segment or not. I'm going to do a cheater bulk comment around this for the moment. It's not generally how I prefer to do things, but we'll come back to whether or not we want to have an on-segment function with tests later. I want to see what this cleaned up. Right. So we get rid of the expected slope for these segment calculations. And this is getting rid of so much like hard-coded special math stuff that I didn't ever like. So I'm happy to be getting rid of this. All right, the test pass. Yeah, in C++, I've gotten in the habit of using more free functions lately and fewer member functions. But then I was thinking about the fact that you don't have type-based overloading in Python. And one of the real strengths of using free function in C++ is that we allow the type system to determine which function by a given name to call in a given scenario. And we don't have that same strength available to us in Python. So I've been finding myself leaning slightly more towards having member functions, because then I let the dot notation determine which actual function is going to be called instead of the type system. So I just throw all that out there because if anyone has an opinion on that matter, then, feel free to comment on it. Yeah, looks like we're clean still after getting rid of that stuff. We weren't really using it anyhow, just for the line merging. Excuse me. My cold is messing with my voice now. I don't know how much longer I'll be able to do this today. All right. Oops. Something like that. All right, I'm going to check my to-do list and see where we are. Wait, this says I have. Oh, right. Okay. So I removed the segment intersection formula, or moved to a segment intersection formula, removed all references to the line object. We have a conversation we need to have. And I will pull it up and again let you all comment on this, although you seem to have gotten rather quiet over there. An equivalent thing to shaders, I think I would have to do all of that math from scratch. I think it would be a an algorithmic texture, effectively. Okay, let's go back to camera here. Now, currently, I'm doing a fairly standard. This is, positive y. This is positive x. This is negative y. And this is negative x. Now, where I've gone a little off the rails here is if I have something like a ray, and it's pointed off in this direction, like this, it's, well, in this particular case, I just made its origin 0, 0. Now, the angle that I represent this ray in is I've gone with compass coordinates. So it's the angle from here. And I've been debating if I did all this without having any idea at all what I've been doing, and I've just been doing a little bit of research. I wonder if I should do standard polar coordinates, or if I should keep with compass coordinates for my rays. I don't know which one makes the most sense. So if anyone has a comment on that, then go ahead and feel free to comment on that. I need to document what I'm doing at the very least. So let's go ahead and do the documentation. That's in my geometry in the ray. And I need to learn how doc strings work. And I kind of feel like that seems, why am I getting this squiggle? At least 2 spaces before inline comment, fine. I feel like this somewhat makes sense because my camera object also has a direction, and that is also the same thing. So they are at the very least equivalent. So I guess I'm going to just leave that how it is at the moment. And then I'm going to see what the next item on my to-do list was. The next item on my to-do list was to discuss the optimizations that I'm currently doing. And so I'm going to, like I said several times before, edit this down into a bunch of smaller episodes. So let's do that real quick, and then I'm going to probably get off for the evening because I am losing my voice. So the optimizations that I currently have, I'm doing a couple of things. Several of them like don't even matter anymore, and I'll explain in a moment. But the main thing that I am doing as an optimization is this code inside the map. So let's go back over this again for people who haven't seen this. I've got a tiny little DSL defined where, depending on which ASCII character you have here, it determines what kind of wall chunk to build. So when we've got a / and we are building this upper left triangle, that is actually being built as 3 line segments. It's one across the top, one down the side, and one diagonal. And if it is a block, that is 4 line segments filling in this entire chunk of grid space. And they are every 1 unit of map coordinates. So these are 1, 2, 3 each, 1, 2, 3 each, and this is 4. And so if you look at this, I've got like all of these wall chunks. So there's, in between these 2 pieces of wall, here, I've got 2 line segments, and they need to be merged. So I build this thing from the map, and in the map code, I go in and build all of the chunks, and then I have this terribly inefficient and poorly written algorithm that goes through and it looks for any chunks that can be removed. First of all, I know that if any segment exists twice, then it was between 2 map items and it can just be immediately removed. And that's done with a handy little list comprehension here. item for item in result if result.count of item equals 1. So exciting. So I have the result. If there's exactly one of those line segments, then I save the item into the result again. If there is more than one item in the list of segments, then I don't save it because I know it was two adjacent duplicated walls. And then I go through all of these, and it's just this math that I was showing earlier here, where if I've got two line segments, this is the stuff we were just working on, that are, I guess, collinear with each other and have an endpoint shared, then I merge those two into one line segment. It's not really a complicated idea, but it is significant for the performance of this. And if we can hit play real quick, we can see, now I'm going to go ahead and hit stop immediately, that I had 524 line segments initially, 316 after I removed duplicated ones, and then after I merge end-to-end ones, 167 line segments. So I'm going to go ahead and hit play again, and you've seen this. If I'm staring at this wall, I'm getting in the like 20 to 30 frames per second with PyPy here. And if I were to update this code, let's see, let's just here return this without doing any filtering at all. Now you can actually see all of the wall segments, which is kind of cool. And, well, interestingly, it's not nearly as slow as it used to be. So maybe this is considerably less relevant today because of other smaller optimizations that I've done along the way. Okay. Yes, it removes all values that have duplicates. That is exactly what I wanted to do. I keep the items that don't have duplicates. It's not the equivalent of putting it into a set. It's intentionally removing both of the duplicated items because that's where two wall segments in my map happen to intersect. Okay, so then when I am actually doing the gameplay here, I come through and I get all of the rays that happen to intersect. Okay. Yeah. And then I draw the closest wall that matches me. Eventually, we're going to change this so we don't draw just the closest wall. We're going to theoretically be able to have windows and such, and so we'll draw the segments behind that as well. Let's go into this intersect ray segments. Okay. Yeah, so the segment intersection code is way faster than it used to be. I had previously been doing a bounding box test to say, well, only check this segment if there are, if it makes sense to check them, if it's within the bounding box of the area. And so I was doing a pre-filter of a bunch of segments. So let's, again, do a quick test here. Yeah. If I get off into nowhere, then I'm still in the 100 and something frame world. Interesting. Yeah, so that optimization is way less necessary than it used to be. That is actually very interesting. So it is definitely an advantage that we just did the faster wall segment intersections than we had been doing before. Yep. Okay, so there we go. The current optimizations, stupid simple, because we fixed our line segment intersections. And as you can hear, my voice is failing, so I am going to go ahead and get off today, and I'm probably going to stream some tomorrow. And what I really want to do tomorrow is pull out everything that's Pygame specific, pull it up, and just have some simple like create me a screen and draw some lines and be able to optimize, or not optimize, but genericize some of this so that we can do other things in the future. And then we're going to do things like a timing loop and a mini map, and we'll be having fun. Okay, awesome. Well, hopefully you all had fun. I had some fun. I will catch you all later.